Hello, Code Monkeys. Today we're going to take a look at structures. The video I promised you 2 videos ago and then skipped over for the debacle that turned out to be the pointers video. I think we're going to end up redoing that one at some point, but for now it stands as is. Let's get into it. Check out what's in our handy dandy work folder. Looks like there's already something called structures.c, so we'll just clear it out with the same echo line we always use. And we'll go ahead and look inside. Structures.c. Man, spelling's hard. And, as usual, include standard input output.h and standard lib.h. Main will always return an integer. It will always take an integer called argc, and haha, we don't need and. Character double pointer argv. Don't forget to actually return 0. Spelling's hard. 0. All right. So if we're going to define a structure, we can do that without the typedef. I guess you would call it a directive function. It's built in. But it makes things a little easier if we use it. So we start with typedef. And the keyword struct. And structures will be contained between braces. And you got to give it a name at the end. We will make a node. Don't worry about what exactly a node is. It is a surprise tool that will help us later when we start talking about lists, graphs, that sort of thing. A node is going to have an integer called data. Very creative, isn't it? And a node pointer called next. But since node hasn't been defined yet, we can't actually use that. So we're going to make a void pointer. Now, to instantiate our node, it's quite easy. Same way you instantiate anything else. Node n0. And just for giggles, we'll make a node pointer called n0_p. And we'll just go ahead and set that equal to the address of n0. Now, to do anything interesting with our structure, we have to be able to access the insides. There are 2 ways of doing that. One is directly given the node itself. So we can do something like this. n0 dot, I believe they call that the scope operator, data equals, let's make it our favorite number. And we can actually do it with the pointer. _p, and we use this operator that will unpointer our node pointer. Oh my. We don't need to reinstantiate a node down here. Look at me, all out of sorts. You will never ever do this in real programming with pointers like next is. This is just for demonstration purposes. You generally / always want to get pointers from some function that returns a pointer. Very important. But again, for demonstration purposes, we'll do this. And of course we want to see what we did, so printf always ends with a new line. At least when I do it. Let's look inside our node! Exclamation point. We could do this all on one line, but it's all about readability. And we want to know what the data is. And the data is an integer. And we want to know what next is. I worked this out ahead of time. The pointers in this particular implementation of C are long integers, so you have to do that just a little differently. And close our quotes. We want... let's be interesting with it. Data and n0 dot next. Now it will complain at us if we try to do this with a pointer, so we'll cast it as a long integer. Hurrah! And I believe at this point we're good to save this and compile with our usual GCC force ANSI compliance. Define the output file. This is going to be structures.o, and the input file .c. So. Okay. This is because we were naughty, but this is fairly easy to fix. It does not want to... I believe it actually compiled. This is just a warning. But it's usually a good idea to clean those up anyway, because a warning usually means you're doing something wacky, which we are. And we will go ahead and call this a... I think we can just go ahead and call this a node pointer. And it shouldn't complain too much about that. Yeah, all pointers are the same, even if they're void pointers. We'll go ahead and... Oh, we haven't executed yet. Haha, gotta type it myself. .o. Ooh, we forgot our new line. Isn't that silly of me? But, as you can see, we managed to get our data back out, even our bum pointer that we created. Oh my, that has hidden itself quite nicely behind my picture there. There we go. I think I'm going to have to go back and redo a lot of these videos. All part of the learning process, kids. Let's take a look at the source code again. Let's go ahead and change that, because that bothers me something fierce. And the last thing I want to show you is very similar to what we saw in the last video. We are going to go ahead and declare our node using malloc. So go ahead and comment that out. I'm going to keep this node pointer n0.p, but we'll just use a malloc there. I don't think you actually have to do that cast. It shouldn't matter. Size of, once again, node. And there's no n0 anymore, so we're going to need to do our underscore p and our pointer operator instead. And the same thing over here. Underscore p. That should do the trick. Go ahead and compile it with our usual GCC line. And execute. And as you can see, we got nice stuff there. Exactly what we wanted to see. Alrighty, that's going to be it for today. I hope you all learned something today, and have a good one.